I'm going to pull up your guys' notes because there's quite a few notes for section 1.2. Alright, so if we're looking at some function types, a linear function is always in the form y equals mx plus b. And linear means it forms a straight line. If we're looking at a polynomial function, that's a function that has exponents. So like a sub n x to the n plus a sub n minus 1 x to the n minus 1, etc., where your exponents go in decreasing order. So like you might have a function with x to the 4th plus x cubed plus x squared. That would be a polynomial function. A quadratic function is a type of polynomial function where your biggest exponent is 2. So anything ax squared plus bx plus c. A cubic function is a specific type of polynomial function where you have an exponent of 3. So like ax cubed plus bx squared plus cx plus d. A power function is any function with x to some number where that number is a constant, so like x squared is a power function. Here, let me scroll down a little. Yeah. You still good, Mark? Okay. A root function is any function with x to some exponent, which is a fraction, or some type of root function, such as like a cube root, 4th root, square root. A reciprocal function is a specific type of power function where your exponent is negative, so x to the negative 1. You guys still okay? Yeah? Okay. A rational function is a function that is a fraction where you have a polynomial divided by a different polynomial. An algebraic function is anything that has a plus sign, a minus sign, a multiplication sign, a division sign, or a root sign in it. Trigonometric function is just a function that includes any of your trig identities or models that you have, like sine, cosine, tangent. Any of those would be trig functions. All right, and our last two, an exponential function is any function where your variable forms your exponent. So a to the x, where a is some constant number, is an exponential function. And a logarithmic function is a function that has a log. Okay, so the first part of your assignment is just going to ask you to classify various models of functions based on what type they are. if I look at part A, that gives me f of x equals 5 to the x exponent. And what type of model do we know is where our exponent is a variable?
The exponent is a variable?
Yep, our exponent is up here, is our variable. Which model matches that?
Power?
Power is where your exponent is a number.
Oh, exponential.
Exponential. Yep. When your exponent is your variable, then we classify that as an exponential function. Okay, so then if I look at part B, x to the 5th, what type of function would x to the 5th be then?
Power.
Yep, that one would be a power function because your exponent is a number. Alright, if I look at part C, h of x, where I have my function is a fraction, which one of those different models that we look at is function is a fraction?
Rational.
Yep, rational function. Any type of rational function is a fraction, which kind of makes sense because it has the word ratio in it, and ratio means fraction. Alright, and then my last function, f of x equals 1 minus x plus 5x to the 4th. Well, this one kind of throws people off sometimes. A quadratic, it would be quadratic if this was a 2.
Polynomial.
And polynomial has to have decreasing exponents, so like 4, 3, 2, 1. So this one only has 4 and then a 1 and then a constant. What do we know about plus and minus? Yeah, algebraic. It has pluses and minuses in it. So it's algebraic.
It would only be algebraic just because it has just the signs, right?
Mm-hmm. Alright. That's the first part of what it asks you to do. The second part of what your assignment's going to ask you to do is take tables of values and figure out which type of function matches them. So there's a lot of values in here, right? So the table is actually in your book under example 2. We're going to put it into our calculator. So go ahead and turn on your calculator, and we're going to plug these values into our calculator in a way that makes us easy to visualize the function. So once your calculator is on, if you go to your stat screen, and then you go to edit, it's going to take you to your 2 lists. Okay, and I start out at 1980, so 1980 is going to be my year 0. And then I go to 1982, so that would be like year 2. 1984 is year 4, etc. And it goes up by 2s. So all of your years are just going to go up by 2s. Until you get to 28. Okay. Yep, and then for your other values, you're just going to leave those exactly the way they are. So 338.7, 341.2, next one, 344.4, All right, and once we have our lists entered, then we're going to get out of that screen and go to our y equals screen. Page 25. Okay, and once you're on your y equals screen, then arrow up to plot 1 and hit enter so that it'll be highlighted so that your plot 1 is turned on. And then we're going to adjust our window so we can actually see things. So we know that our x values went from 0 to 28, and they went up by 2. So your x min is going to be 0, your x max will be 28, and you know that your scale will be 2 because they went up by 2. Then we know that our y min was right around 338 because it was 338.7. And our y max, our very largest value, was like around 385.6. Yeah, so 386. And if I kind of look at how much those are going up by, they appear to be going up by approximately 3 each time. So I'm going to look at my y. I'm going to set my y scale to 3. And then I'm going to click on graph so I can see what it looks like. Okay, so once I do that, I've got a graph that it's got a bunch of dots from my table of values, and I need to determine what kind of model I think that looks like. So if we were to try to connect a line to make those dots, what kind of line would we probably approximately have? Would it be a straight line, a curved line, a quadratic? It would be a diagonal line. Would it go like straight though, or would we kind of curve, or how would we do that? Straight line, okay, right, it kind of forms a straight line. And this won't let me draw on it, but it kind of forms a straight line. And a straight line is a linear function, so we're going to figure out what our function would be if we wanted a linear function. So click back to stat, and then arrow over to calc. And we're going to go down to our linear regression, which is number 4. Ax plus b is a linear function. And we're going to hit enter. Okay, then it pulls up where we're pulling our lists from. So we know our x values came from list 1. We know our y values came from list 2. You can ignore the frequency list and the store regression. Arrow down to calculate, hit enter, bless you. And so what that tells us is that my slope, which is represented by the letter A, is approximately 1.66. And that my B value, where am I crossing my x-axis at, is approximately, or my y-axis is approximately 337.34. So we determined that our function was a linear function, that it formed a straight line. And we determined that our function equaled approximately 1.66x plus 337.34. And then it wants us to figure out what would happen in the year 2015. And so if 1980 was my 0, then I'm going to subtract 1980 from that to figure out my x. So 35. So 35 is going to be the x value that I'm going to plug into this function to figure out what would happen at year 2015. So 1.66 times 35 plus 337.34. If you plug that into your calculator exactly like what it looks like on the board, it should give you the CO2 levels in year 2015. And so what do we get for that? 395.44. So those would be our approximate CO2 levels in the year 2015. Okay. So mostly what you guys are doing today is identifying function models. You're going to do page 33, 1 through 4, then 10 through 13, and 19 through 22. Yeah.